Okay, so this is the last set in Adventure 7 that you're going to be working on here. Simplifying square roots 2, and we're going to be multiplying expressions containing radicals. So 2 times root 275. So what I'm going to think about here as much as possible is there a perfect square in here? And if I think of this, I'll tell you how I always just do this. You know, $2.75. I know that 25 cents, I know that 25 is a perfect square, and it goes into $2.75. I could make this into quarters, right? $1 has 4 quarters, $2 has 8 quarters, and this would be 3 more. So this is equal to, right, a quarter, 0.25, times 11. That's the same as 11 quarters, right? Now there was no 2.75 here. It's just 275. So it's the same thing as 25 times 11. So if I said the square root of 275, I could rewrite that as the square root of 25 times 11. And that can be rewritten as the square root of 25 times the square root of 11. And that, I can take my perfect square, so take the square root of 25 and say, what is the square root of 25? Well, that's equal to 5 times root 11. So I could rewrite this as 2 times, and I just stick this whole thing in here because that's the same as to square root of 275. These two are equal. So 2 times 5 times root 11. Well, what's 2 times 5? That's 10 root 11. Oh, sorry. Oh boy, let me get back in there. And I'm going to put that in as 10 root 11. But I'm going to check it because I don't like getting things wrong, and I want to see if the calculator agrees with me. 2 root 275. So what would that be like? 2 times the square root of 275. And I see that it does agree with me. That's 10 root 11. You know, I could just have done the square root. If I wanted to check that out, I could have gone the square root of 275, and I would have seen that that was 5 root 11. It would have helped me with that, right? And then just times 2. If I have 2 sets of 5 root 11, that would be 10 root 11. So anyway, it's 10 root 11. Let's go to the next one. 6 root 176. So 6 square root of 176. I get 24 root 11. And 6 root 55. 6. Root 55. And that cannot be simplified any, does it? It doesn't look like it can. Are there any perfect squares in 55? Well, I see that 11, but I'm not going to get thrown off by it because 11 is not a perfect square. And 5 times 11 is also not a perfect square. So I can't simplify that at all. So 6 times root 55 is how it stays. 6 root 55. It's good to know, man. Some of these cannot be simplified. So 3 times root 45. Now I happen to know that root 45 is 9 times 5, right? But I'm going to put it in there, and I'm going to get 9 root 5 because this is square root of 9 times the square root of 5, right? And the square root of 9 is 3, so this is 3 times root 5, which is 9 root 5. So that 9 root 5. 12 root 325. These are just so much easier to do with your calculator. So 325, instead of worrying about them, I just put them in like that. 60 root 13. And you know, I don't really see the value in doing it any other way, because this time we're always going to get it right using this technique. And in the business world, they would want you to use this technique, right? And any kind of job you'd have, your boss would want you to get the exact answer correctly and use the calculator. As long as we understand all these rules about exponents and what it means, we can use our calculator correctly. Okay? So there we go. That's how that is done. Go ahead and finish it. That's your last exercise for Adventure 7.